process for loading the image is from MathWorks documentation. We get help for the filter for blur from Sub and he is credited. The rest of the code is original. Our ENCMP 100 contest submission is an image processing app. The goal for the app was to allow the user to load their own image and easily apply different transformations. We want to teach people about the processing capabilities of MATLAB. The basis for the project is the image functions. This app has many features. They are listed below. First, we planned our app and decided on using App Designer. App Designer is used to create a user-friendly graphical user interface, or GUI. We also decided which functions to create. In our initial version, the main focus was functionality. The goal was to ensure that functions were up and running. In this version, the main issue to tackle was loading the image and saving it. To display the image is displayed on an axis. The axis figures are hidden so only the image appears. In version 2, the other functions that were harder to create were added. The most technically difficult function, blur, was added at this stage. At this point, every function worked on its own, but there were major bugs and details to be hashed out. Errors popped up when applying successive transformations.
Create a blur function. We implemented several switch cases for different desired intensities from the users. Depending on the intensity, the switch cases activate filters of different blurring intensities, which take the average color value of adjacent pixels. It then applies it to the entire image. The output image in ENCMP is then displayed. Version 2 introduced the possibility of functions working solo, but handling multiple transformations were another matter in of itself. Version 3 handles these issues. This function worked toward ensuring the transformations will work together. If they can't, error dialogues were introduced. Errors for bad user inputs were also introduced. The final version, version 4, was all about making the user experience more friendly. This was the most time-consuming stage of the project. The concept of extreme cases were dealt with in this version, which will be discussed later. Furthermore, user-friendly warnings were added. If the user were to apply a transformation, then try to close the app, a warning screen will remind the user to save.
Here, we will show the app in action. After the app is ran, the user is to first load an image. After selecting the load button, a pop-up will appear and the user can select an image. The image is displayed on the screen and the user can then apply transformations. In the app, the user can see changes to the photo in real time. For example, we will apply grayscale option onto the photo. From there, we can apply the blur function to blur it. When the user is finished, they can click the save button to save their image. Clicking the save function will pop up a file in which they can save the image as a JPEG file.
While the app is strong, it does have a few pitfalls just like any other app. After extensive testing, some problems were found. The biggest issue is that after applying blur, any rotations applied will result in a white image. This is because our output image type after applying blur is uint8, while the rotation function converts the image first into a double, then applies rotations. The image conversion messes up the output image. To prevent this, error dialog is displayed when a user tries to blur then rotate. A workaround is that the user should first apply rotation then blur. Another unfixable issue is that each rotation that isn't a multiple of 90 degrees makes image smaller, reducing image quality. This is a known problem with MATLAB. A workaround is to crop a rotated image, which reverts the rotated image to almost the original size.
Here we are in code view. Two different moments will be discussed. They occurred at different stages of the coding project. After deciding to use App Designer, the first hurdle was the aspect of taking the image and allowing it to be used across functions. The solution was to create a variable with private access that can be exchanged throughout each function as shown in this code. The image could be stored as a variable and used throughout. The initial idea was to create a global variable to be used, however that proved to be unfruitful. The next challenge was creating the extreme cases. The specific extreme case we will discuss is determined if the file type is allowed, as shown here. To solve, we created a vector with all of the allowed file types in it, then take the file extension of the inputted file and compared it to each aspect of the vector. An error is triggered if the file extension does not match any of the allowed file types. Check comments for further details.